Hello everyone, in this class we are going to continue with our examples of time complexity. So let's start. Let's say the problem is given as function. Within that we have a loop for I equal to n, I greater than 1, I minus minus, and then we print as d. Now what will be the time complexity of this particular problem? Look, this particular statement will take constant time. Now how many times this particular statement will execute? That means the number of iteration for this particular for loop. So look, the loop variable here is I and the value of I start from n. That means the value of I start from n and it will continue till 1. No, sorry, this is not 1. That is, the termination condition here is I greater than 1. This is our termination condition, and the value of I is decremented by 1 only. That means what will be the value of I in each iteration? That is, in first iteration the value of I will be n, and then in next iteration we will get the value of I will be n minus 1, and then we will get n minus 2, and like that it will continue till 3, then 2. These are the values of I for which this loop will execute. That means how many numbers are there? Now there are total how many numbers? There are total number is n minus 1. Clear? So total iteration will be n minus 1, and each iteration takes c time. Each iteration takes how many times? C times. That means total time will be how long? C into n minus 1. That means cn minus c. So what is the term that have number of input? That is, this term only have the number of input. So what will be the time complexity? The time complexity will be order of n only. Clear? So this is how we can find the time complexity, by finding the number of iteration only. Clear? Next, change the question little bit. Let's say now the value of I will be decremented by 2 in each time. That means what will be the time complexity now? So to find the time complexity, again we need to find the number of iteration first. So how to find the number of iteration? So for that we need to know for which value this loop will execute. So again start from n. The next value will be n minus 2, because each time the value of I is decremented by 2 only. So after that the next value will be n minus 4, and then the next value will be n minus 6. Like that it will continue till which value? Till 2. Clear? Like that it will continue till 2. Now if we change the value, now there is two possibilities is there is two possibilities we have. That is, the number n is divisible by 2 and the number n is not divisible by 2. So concentrate, we will see both case what will happen. So first case 1 is n modulo 2 is 0. That means n is divisible by 2. Let's say n is divisible by 2. And the second one, other one, that means case 2 is n not divisible by 2. So what will be the case? Let's take an example. In this case, let's say n is 20. So let's reduce the number. Let's say the number is 10. So what will be the value of I? The value of I in this case will be 10, 8, then 6, 4, 2, then 0. Clear? So for these values, for all of these values, the iteration will execute. So how many iterations are there? There are 1, 2, 3, 4, 5. Total iteration is 5, and that is what? That is n by 2. That is n by 2 iteration is there. Now we will see what happens in case of a number when the n is not divisible by 2. Let's take n equal to 11. So what will be the value of I in different iteration? So the value of I start from n, that is 11, and then next value will be 9, 7, then 5, 3, 1. And among these number, for all these number, the loop will execute. So how many iterations are there? 1, 2, 3, 4, 5. Again we have total iteration is 5. So how we get this value 5? Now look at here, the number n is 2, n is 11. So if we divide 11 by 2, at that time we will get 5.5, not exactly 5. So how to get the 5 from this particular 5.5? How we can get that value? That gives us by using the floor operation. If we use the floor operation, at that time we will get 5 as result. Clear? That means in this case the total iteration will be n by 2 or n by 2 floor. So which one to use? Look, in this case also, if we use 10 by 2 floor, at that time we will get 5.0 floor, then we will get 5. So if we use floor, at that time it will generalize the concept. Clear? So what will be the number of iteration? That will be the n by 2 or n by 2 floor. Now look, the value of n, whatever the value of n, we will get how many iteration? The number of iteration will be n by 2 floor. Clear? So we are going to erase this thing. So come here and do the next operation, that is total iteration will be n by 2 floor. So total iteration is this one, n by 2 floor, and each iteration will take c time. So total time will be n by 2 floor and c. So from here we can find we have to remove the term n for time complexity. So this will become approximately, this 2 is a constant, so we can remove this 2 and we left with for time complexity we remove this floor from this particular expression, and we left with n by 2 into c, and from here we will get n into c by 2, and this whole as a whole is a constant, so we left with only n. Therefore the time complexity will be n, order of n only. Clear? Hope you understood the concept. And why we remove this floor part? Because whatever the floor part, that doesn't matter in case of complexity. Because of that reason we remove the floor part from this particular expression. Clear? But if we want to find the number of iteration, at that time this floor is required. This floor is required. So this is how we can find the time complexity when the value of I is decrement each time. So what happened if we decrement it by 3? Same thing, at that time if the number is divisible by 3, we will get total iteration will be n by 3. If the number is divisible by 3, at that time we will get total iteration of n by 3. Or if the number is not divisible by 3, at that time we will get the total iteration as n by 3 floor. The total iteration as n by 3 floor. But again when we come here and we want to find the time complexity, at that time we can remove this floor, because the time complexity we mainly focus on the term number of input, that is n. Clear? We are not going to focus on the constant part. Clear? So among all these things, only this part is important for time complexity. All the remaining parts are not that much important for time complexity, because all the remaining part are going to be the part of constant only. So here what we will get? We will get c by 3, and again this is the only term with number of inputs. So what will be the time complexity of this particular problem? That is order of n again. So now what happens if we change the problem as I divided by 2? Now what happens? Now this is something important. So what happened in this case? In this case we will get the value of I start from n, and the next value of I will be I by 2. That means now the value of I is n, so the next value will be I by n by 2. And what happened to the next value? Next value of I will be n by 2 square. And what will be the next value of I? That will be n by 2 cube. And like that it will continue. How long it will continue? When the value of I becomes 1. That means n by something to some things, it will continue till 1. Clear? Now that means when the value of I reach to 1, at that time the iteration will complete. Now what happened? What happened if now when we will get reach to 1? We will reach to 1 only at that time when n by n, we have n by n. That means this value n, now look at here, each time the value of denominator is double of 2. That means here we have 2 to the power 0, and next we have 2 to the power 1, and next we have 2 to the power 2, and next we have 2 to the power 3. That means in each step we incremented the denominator by multiple of 2. Now if you observe when and then this thing repeats, until when we reach to 1. Clear? Until when we reach to 1. Now if you observe one thing, that when we can get the value of 1, because the numerator of this fraction is always n, that means here also it will be n. So what will be the denominator? We have denominator as power of 2. We have denominator as power of 2, but we don't know what will be the power of what will be the value here. Clear? We don't know what will be the value of here. That means let's say the value here is 2 to the power k, and this whole value must need to be equivalent to 1. Must need to be equivalent to 1. That means, what does it mean? This means we have n by 2 to the power k, and that is equal to 1. So what happened? If we cross multiplication, then we will get n equal to 2 to the power k. Clear? That means we have this 2 to the power k equal to n. So this is one case. Now what happened? This is one case. That means we can reach out to 1 only when the value of n is 2 to the power k. We can reach out to we can reach out to 1 only when the value of n is 2 to the power k. I hope that is clear. Now look at here. When we have n by 2 to the power 0, at that time how many iterations we cover? We cover only one iteration. When this thing happens, that means when we have n by 2 to the power 1, at that time how many iterations we cover? We cover 2 iterations, that is one for n and other one for n by 2 to the power 1. And the next thing, when denominator is 2 to the power 2, at that time how many iterations we cover? We cover 3 iterations, n by 1, n by 2, n by 2 to the power 2. Now here, when the denominator is n by 2 to the power 3, at that time how many iterations we cover? 1, 2, 3, 4. Total 4 iterations we cover. So what does it define? That defines that when we have n by 2 to the power k, at that time total number of iteration will be k plus 1 iteration. At that time we have total k plus 1 iteration. Now look how. Look, here the power is 0 and we have 1 iteration. Here the power is 1 and we have 2 iteration. Here the power is 2 and we have 3 iteration. Here the power is 3, we have 4 iteration. And here the power is k, so we will have k plus 1 iteration. Now, how to find the value of k? We can find the value of a from this particular expression. So, how to find the value of a? That we already know. We already saw one example related to this part. That is, we will take log 2 in both sides. Then we will get log n base 2, and here we will get k log 2 base 2. And whenever log base and element is same, at that time we will get 1. That means here we get k equal to log n base 2. That means total iteration, therefore total iteration will be log n base 2. Clear? But this is true when we have the relation that true when n is equal to 2 to the power k. When the value of n is equal to 2 to the power k. But is there any restriction for the value of n? No, there is no restriction. There is no restriction for the value of n. But here, as per our assumption, we got the value of n is equivalent to 2 to the power k. But that is not the scenario in every case. So we need to cover all the remaining part also. That means when n not equal to 2 to the power k, at that time what happened, we need to look on those cases also. Clear? So now look at here. Let's say the value of n is anything. Let's say we'll take 10. So what happened, the value of I will be 10. After that it will divided by 2. So what will be the next value? That will be 5, and next value that will be 2, and next value that will be 1. So how many iterations are there? Only these many iterations are there. How many iterations are there? Only, sorry, here total iteration will be this plus 1, because we have k plus 1 iteration, and the value of k is log n base 2. Now look at here. What is this? Here the total iteration is how much? Only 10, 5, 2. That means only 3 iterations. Total iteration is 3. Log n base 2, and the value of n is 10. Let's say what happened at this case, log 10 base 2. So what we will get here, this is 10. 10 is not a power of 2, so we can't convert it. So the value here will be equivalent to, look at here, 2 to the power 3 is 8, 2 to the power 4 is what? 2 to the power 4 will be 16. That means this value will be something 3 point something. So it here we will get 3 point some value. But what is the iteration here? The iteration here is 3 only, not more than 3. So we need to find the floor of this particular value. We need to find the floor of this particular value. That means we need to use the floor operation. So we will get only 3, and this is our number of iteration. Clear? Now let's check one more example and confirm this thing is correct or not. So let's say the value of n is 20 now. So the value of I will be 20 and then 10. 20 is again come here. So let's remove this 20 and make it 25. 25, and then next value will be 12, then next value will be 6, next value will be 3, next value will be 1. So how many iterations are there? We have only 1, 2, 3, 4. Because why? Because the loop will continue until we have the value of I is greater than 1, but here we get the value of I is 1. That means in this case the iteration will not continue. So we have only these iterations. That means total iteration here is iteration here is 4 only. Now let's check the value of this thing, log n base 2 and floor. Now look at here, we have 2 to the power 15 and we have 25, and 25 is not equal to 2 to the power k form. 10 is again not equal to 2 to the power k form. So but we have 2 to the power 4 is 16, 2 to the power 5 is 32. That means, and the value of n, that is 25, that is in between these two things. In between these two things, that means this value will give us something like 4 point something, but we don't know the actual value, and actual value is not required for us. Now 4 point something. So what will be the actual value here? After this floor operation we will get only 4. That means this floor operation is correct for the case when n not equals to 2 to the power k. Clear? But whenever we have the value of n is something 2 to the power something, at that time the total number of iteration will be only log n base 2, log n base 2. But whenever the number n is not equal to 2 to the power something, at that time the number of iteration will become this one, log n base 2 floor. Clear? So from these two discussion we can conclude that from the whole of our conversation we can conclude that total iteration will be equal to log n base 2 when n equals to something 2 to the power k, and log n base 2 floor when n not equals to 2 to the power k. Now which one to use and which one not to use, that depends on the options. Look, whenever this kind of problem is given in the exam, in the GATE exam, at that time you will have the option. Clear? And based on the option you have to select the correct answer. If this option is given, at that time this one will be answer. If this option is given, at that time this will be answer. But at a time both they will not give in the option, that is guaranteed. At a time they will not give both of these two options. Clear? So you need to focus on these two scenario when the value of 2 to the power when the value of n can be 2 to the power k, and when it is not 2 to the power k. Clear? So what happened? So we know the number of iteration. Now whenever we know the number of iteration, we are almost done our task. That means in next task we need to find the total time only, and total time will be log n base 2 into c or log n base 2 floor into c. Now the time complexity, again time complexity will be either this one or this one. That means time complexity will be order of log n base 2, or time complexity will be order of log n base 2 floor. Clear? But even though the answer is depend on the option given, but this is more useful because this cover this concept also. This cover, when we use the floor concept, at that time this cover this part also, but this part never cover the floor part.